Uh, we will start module 4. Here we'll be discussing about the characteristics and the quality attributes of embedded systems. So like any other systems, even embedded systems, we do find out their characteristics. We do find out some of the quality attributes, and we'll fix up the issues and we'll make it perform better. So let's start with the characteristics of embedded systems. So each embedded system possesses a set of characteristics which are unique to it. So as I discussed already, the embedded systems are unique in its nature. So even the characteristics also will be unique. So let us see. Some important characteristics of embedded systems are application and domain specific, reactive and real time, operates in harsh environment, distributed, small size and weight, power concerns. So now let's see one by one. Now coming to the first point, applications and domain specific, each embedded system is designed to perform a set of defined function in such a manner to do that intended functions only. So we have seen already so many applications like ovens and washing machines, and even in telecom, there are so many embedded systems we are seeing, and they are meant to perform a specific function. And you cannot use the same board for performing the other task. So embedded control unit developed for a telecom cannot be used to serve another domain like consumer electronics. Now let's go to the next characteristics, that is reactive and real time. What is reactive? Means embedded system produces changes in output in response to the changes in the input. So depending upon the type of input you give, the output gets reflected. Makes sense. So they are referred to as reactive systems. So definitely when you switch on, the systems will be on. When you switch off, it will be off. If you try to perform the other tasks depending upon the different functions, you press several, there will be so many buttons available. Take an example of washing machine, whatever the button you choose, it will perform in that particular way. Now, the embedded systems are real time. In many cases, it can be real time and it may not be also. If the embedded systems are real time systems, means the timing behavior of the system should be deterministic. Means the system should respond to request or task in a known amount of time. Let's take an example of ATM machine. We know that when we enter a PIN, we'll get an acknowledgement. When we try to when we enter the amount, again we'll get an acknowledgement. For everything, we get a confirmation. It goes to the next slide. So for everything, for every changes, there will be a time slot and it is fixed. It has to respond within that time slot. Suppose if there is no paper, it has to give a message stating that there is no paper for printing the acknowledgement. There should be a predeterministic time. If suppose if it is not able to do that within that amount of time, it has to do the acknowledgement. Means otherwise the system gets stuck, it gets hanged. Even for ejecting the cache, it has got a predetermined time. If the cache doesn't come out within that time, it has to drop a message. So that is the meaning of deterministic. Now let's go to the next point, that is operates in harsh environment. The environment in which the embedded system is deployed may be dusty, one or a high temperature zone, or an area subject to vibrations and shocks. In such areas, it should be capable enough to operate. So even the embedded systems should be designed in such a way that it should be in a position to operate in a dusty environment or a high temperature zone or in any vibrations or shock environments. Let's go to the next slide. So now let us go to the distributed systems. The term distributed means that embedded systems may be a part of larger systems. Example, automatic vending machines or ATM. You know that ATM is not just one unit. Internally, there are several parts. What are they? The vending machine contains a card reader. There is a small unit to read a card, a vending unit for vending, a small unit to eject the cash, a small unit to eject the paper. So all of them are small unit. Each of them are independent embedded units, but they put together and it becomes the overall system. Now, and small size and weight. In embedded domain, compactness is a significant deciding factor. Definitely, the embedded systems always, we look into the size factor because as the size increases, even the power consumption, cost, everything increases. And that's the reason we always see the compactness. So most of the application demands small sized and low weight products. So whatever the examples we are seeing, usually it will be low weight handheld devices. Some exceptions are there like ATM machines, washing machines, um, maybe the smart refrigerators. So these, leaving those, the many embedded applications are always small in size. Now coming to the power concerns. Embedded systems should be designed in such a way as to minimize the heat dissipation by the system. As I said, it should be designed in such a way that it consumes less power so that the heat dissipation is less. So these are some of the characteristics. Now let's go to the next slide. Now we will talk about the quality attributes. Now, what are the quality attributes? So you are seeing that it represents the non-functional requirements that needs to be addressed in the design of an embedded systems. The various quality attributes that needs to be addressed in any embedded systems are broadly classified into operational quality attributes, and the other one is non-operational quality attributes. So we will see both. So there are two different. One is the operational quality attributes. So what do you mean by operational quality attributes? It refers to the relevant quality attributes related to an embedded system when it is in the operational mode, when it is operating. So that time we will be checking some of the quality attributes, and the other one is non-operational. It is not operating, but still we check some of the quality attributes. How is it different? We will see that one by one. Now let's go to the operational quality attributes. So what are operational quality attributes? Response. The first thing is a response. Response is a measure of quickness of the system, how quickly one will respond. It gives an idea about how fast your system is tracking the changes in the input variable. So you're trying to change the input immediately, it should give a response. For example, there should not be any delay in the flight control application. So this is very crucial system. So flight control applications are very crucial. So the embedded systems used in that, they have to respond it immediately. So, but there is no time constraint on an electronic toy. So you can think electronic toy is also a small embedded system, but here there is no time constraint. But there, the embedded systems used in the flights, they have a time constraint. So the response time is more important. So in this way, depending upon the type of applications, the quality attributes also varies. The response is one attribute, but it again depends upon the even which one we are trying to see the response, whether it is a critical systems or a non-critical system, something like this choice. So based on that, we take that as a major parameter. Now let's go to the next one, throughput. It can be defined as a rate of production or operation of a defined process over a stated period of time. So the rate of production or operation. So throughput, how much of output the embedded system is giving. As I said, this can also be used, embedded systems can also be used in many manufacturing sectors. So how much a particular vending machine or it is able to vend a particular item, and how much quantity it is able to produce in a stated period of time, maybe a month, 6 months, like that. So that talks about the throughput of the embedded system. Coming to the reliability. So what is reliability? Reliability is a measure of how much percentage you can rely upon the proper functioning of the system. Reliability is a measure of how much percentage you can rely. So I can rely upon that 90%. So, or what is the percent susceptibility of the system to failure? So 10% it is not reliable, means let me just take an example. I've used a particular system 10 times. In that 9 times it has worked, 1 time it has not worked. So that is how we take the percentage. So mean time between failures and mean time to repair are the terms used in defining reliability. So what is this mean time failure? Means a particular system has failed for every 1 hour. So take the average time, or maybe like this system, one particular system has had a failure at 10 o'clock, and after that 12 o'clock. So there's a 2 hours difference. Again at 1 o'clock, again 1 hour difference. So 2 plus 1. So you take a mean of all that. So the mean time between failure, the first failure, second failure, third failure, fourth failure. What is the time taken between them? I'm repeating, the first failure happened at 10 o'clock. The second failure happened at 12 o'clock. So what is the gap? 2 hours. Again, the third failure happened at 1 o'clock. Again, between 12 to 1, there is 1 hour. So take the mean. So take the mean of such failures. What is mean time to repair? How much time it has taken to fix up in each failure? 10 o'clock, there was a failure and it took 10 minutes to fix it. 12 o'clock, there was a failure. It took 20 minutes. So take the mean time, 10 plus 20. Again, 1 o'clock, there was a failure. It took again 10 minutes. Add 10 to that. Take the mean of that. So that is mean time to repair. So this is how we see some of the parameters of a particular system. So all these things are part of the quality attributes. Let's go to the next slide. Maintainability. What is maintainability? Maintainability deals with support and maintenance to the end user or client in case of technical issues and product failures or on the basis of a routine system checkup. So for example, we use water purifiers. So they come for a routine checkup, 6 months, 1 year, like that. It can also be classified into scheduled or periodic maintenance. It can be, we are scheduling it, or it could be periodic. So automatically for every 6 months, 1 year, like that. It is automatically, you have to verify the system, or you are fixing this, let us check it for every 1 month. So you're fixing a schedule. So maintenance is very much important at the end user or the client side. Next, security. Confidentiality, integrity, and availability are the three major measures of information security. What is confident? Even the embedded system works upon the security issues. So now let us see. Confidentiality deals with the protection of data and application from unauthorized disclosure. You're protecting the data from unauthorized disclosure. Integrity deals with the protection of data and application from unauthorized modification. You're not letting other person to modify. Availability is the protection of data and application from unauthorized users. You are not providing it to any of the informations to the unauthorized users. See, these are some of the definitions. So safety. So safety deals with possible damages that can happen to the operators, public, and the environment due to the breakdown of an embedded systems. Many a times the embedded system may lead to some disasters also. So you have to monitor its safety aspects, and you have to somehow ensure that it doesn't cause any damages to the systems. So not many a times they do take care, but sometimes a hazard happens, means it may affect. So you have to monitor the safety issues of the embedded system.